Okay. This is an indefinite integral, and it's too complex to solve, because it has too many variables and stuff. Okay, so the first step that you want to do is complete the square, because there's really nothing we can do with this right here. So you go over here and you complete the square, so it's factorable, and so you need a 1 right there in order to be able to factor into 3x plus 1 and 3x plus 1. And then if you add a 1, since you have minus 8, you need to also minus 1, so that's why it becomes minus 9. So then you have 3x plus 1 squared minus 9, square rooted, and then so you can do a u substitution. You make u equal 3x plus 1, and then the derivative of that is 3dx, and that's what du equals. So then you can bring the 3 out front of the integral, and you have to divide it, because that's what, like, dx is 1/3 du. So then you substitute that, and then you substitute the u, and then u squared minus 9 is basically x squared minus a squared, a being 3. And so when you have that, you come over to your triangle, and you know you need to use a secant theta, and the derivative of that is a secant theta, tangent theta, d theta. And so then you want to plug that into your u, and then you plug this into your du. And so this over here, a squared secant squared minus a squared, is a tan theta. So then that's an identity. So you plug that in down there, and then the 3's can cancel and the tangents cancel. So you have secant d theta, which is 1 over cosine d theta. And then in order to be able to integrate that, you have to multiply it by cosine over cosine, which is equal to 1. So then you can make w equals sine, dw equals cosine d theta, and so that would get rid of those two, and then cosine squared is equal to 1 minus sine theta, and we made sine w, so then that's 1 minus w squared. And that bottom is still too complicated to integrate, so we're going to go up here, and we're going to make it a plus 1 minus w, plus b over 1, or 1 plus w, because when you multiply those out, you get 1 minus w squared, so that's just like factoring that out. And then you have to figure out what a and b are, and by doing that, you multiply this out, and then you say, like, w equals 1, because that cancels out the b, so 2a equals 1, so a equals 1/2, and same with down here, b equals 1/2. And then so down here we do that. You can bring out the 2 to the outside of the integral, so it becomes 1/6. Then you can integrate that really easily. It's just the natural log of the bottom. And so you do that on each side, and then you have to re-put in the substitution. So we have w is sine of theta, because of over here. And so then sine of theta, you go back up to your triangle, and the sine of theta is opposite over hypotenuse, which is we just called it x, but really it's u. So you put that down here, and then u, we said, was 3x plus 1. So you put in for u, and that is your solution, plus c, which is an arbitrary constant.
And exactly what does that mean?
It's an indefinite integral, which means this is some graph, and so this means the area under the curve of the graph. So let's say we wanted from 1 to 3, so there'd be some graph. I don't know what it would look like, but let's say, like, this is the graph of that, and from 1 to 3. So the integral is from 1 to 3, all of this down here. Because, say, like, normally, like, you would just go, like, side times side, but since this side's all curvy, what it's essentially doing is breaking it up into an infinite amount of rectangles. And so, see, the smaller the rectangles get, because you could go up here and over, and then up here and over. And so the smaller the rectangles get, the more accurate the estimation. And so an integral is really just the limit as b approaches infinity of the function, of the sum.
And where would I use this?
I can't tell you that.
Alright. And are you enjoying this?
Yeah, I enjoy this. I like integrals and derivatives. I don't like area or volume. Area is okay, I don't like volume.
Thank you very much.
You're very welcome.